Hello everyone. Today we are going to see in trusses how to find the zero members and shortcuts to find the member forces in some cases. Before seeing the rules, we must know which are collinear members and which are non-collinear members. Let us take this joint. In this joint there are two members. Both of them are in the same straight line. Since these two members are in the same straight line, these two are called collinear members. Similarly, in this joint, these are two collinear members. In this joint, these are collinear members. And in this joint, these are collinear members. Non-collinear members are just opposite of what we have seen. If in a joint two members are not in the same straight line, they will be called as non-collinear members. You can see that in this joint, these two members are not in the same straight line, so both of them are called non-collinear members. Let us see the rule number 1. If a joint has only two non-collinear members and there is no external load or support reaction at that joint, then those two members are zero force members. You can see that in these joints we have only two non-collinear members and there is no external load or support reaction. In this case, the two members will be zero force members. These two will be 0, these two will be 0, these two will be 0, these two and these two will be 0. Now let us see the rule number 2. If three members form a truss joint for which two of the members are collinear and there is no external load or reaction at that joint, then the third non-collinear member is a zero force member. You can see that in all of these joints there are three members. Out of three, two members are collinear. These are collinear. And in these joints there is no external load or reactions. Then the third non-collinear member is a zero force member. These are the third non-collinear member. As per the rule, these are the zero force members. Now let us see the rule number 3. If in a joint there is a member and a load or a support reaction and both are collinear, then the second non-collinear member is a zero force member. Let us take the joint A. In the joint A, there is a member force and load which are collinear. In this case, the second non-collinear member is a zero force member. That means FAC will be 0. Now let us replace the loads with roller supports. We know that in the roller supports there will be only one reaction. In this case also FAC will be 0. Now let us see the fourth rule. If a joint has only two collinear members which act in the opposite directions with each other, both of the members will have same force and the same nature. In all of these joints, there are two collinear members which are acting in the opposite directions with each other. For example, in this joint, this member is acting upwards, this is acting downwards. In this case, both of the members will have the same force. Suppose this is 5, this is also 5. If it is 5, this is also 5. If it is 5, this is also 5. And if it is 5, this is also 5. Also, they will be in the same nature. That means if this is tension, this also will be in tension. Suppose this is compression, this also should be compression. Now let us see the rule number 5. If a joint has one member and a load or reaction which are collinear and act in the opposite directions, the member force will be equal to the load or reaction value and it will be in tension. You can see that in the joint A, There is a load and a member. Both of them are collinear and both of them are acting in the opposite direction. In this case, the value of FAP will be equal to the load 20 and the nature of the force will be in tension. Now let us see the rule number 6. If a joint has one member and a load or reaction which are collinear and act in the same direction, the member force will be equal to the load or reaction value and it will be in compression. You can see that in the joint A, there is a member and a load. The load and the member force are acting in the same direction. For example, the load 20 is acting upwards. FAB is also acting upwards. Here FAB is acting towards the right side and the load is also acting towards the right side. In this case, the member force FAB will be equal to the load 20 and the nature of the force will be in compression. Now we are going to see some examples. In these examples, we are going to use the shortcuts. In this truss, in the point B, there is a roller support and in the point C, there is a hinged support. In the roller support, there will be only one reaction. Here, there is only vertical reaction. And in the hinged support, there will be two reactions, horizontal and vertical. We can apply the rule sigma h is equal to 0 and find hc. To find Vb, let us take moment about C. Let us keep clockwise as positive and anti-clockwise as negative. The load 20 is acting in the clockwise direction so that it will be positive and the distance is 4. Vb is acting in the clockwise direction so that it is also positive and the distance is 4. So for Vb, we will get a negative value. That means our assumption is incorrect. We assumed that Vb is acting upwards, but actually it is acting downwards. So we have to change the direction of Vb. Here I have changed the direction of Vb. In this truss, there is no vertical load. So the value of Vb and Vc will be same. Both of them will be 20, but the direction will be different. Vb is acting downwards, so Vc should be acting upwards. Let us take the joint D. In the joint D, we have FDE and FCD. Here let us apply the rule number 1. If a joint has only two non-collinear members and there is no external load or support reaction at that joint, then those two members are zero force members. In this way, both of them will become zero. Then let us take the joint A. In the joint A, there are two forces, FAB and FAE. Here also we can apply the same rule. So both of them will become zero. So there are four zero force members. To make the analysis easy, we can remove these four. Here you can see that I have removed them. Now let us take the joint B. In the joint B, we can apply the rule number 3. So the member force BC is 0. We can remove that. You can see that I have removed that. Now again let us take the joint B. Here we can apply the rule number 5. 20 and FBE are acting in the opposite direction. So FBE will be equal to 20 and nature of the force will be in tension. Only one member is left out, that is CE. We can take the joint C and we can apply the rule sigma V is equal to 0. 20 is acting upwards so that it will be positive. FCE is inclined. We have to resolve it in the vertical direction. We need to find this angle. Let us take this triangle. In this triangle, the opposite side and the adjacent side are 4. In this case, the angle should be 45 degree. So this angle also should be 45 degree. FCE is acting upwards so that it will be positive and we have to multiply with the cos 45. For FCE, we will get a negative value. That means it is compressive. Here I have tabulated all of the forces. Now let us try with this example. In this truss, in the point A, there is a hinged support, and in the point G, there is a roller support. So in the point A, there will be two reactions, and in the point G, there is only one reaction, that is horizontal reaction. By applying the rule sigma V is equal to 0, we can find VA as 40 kilonewton. To find HA, we can take moment about G. When we take moment about G, we should not consider HG, 40 and this 20 because for them there is no perpendicular distance. HA is acting in the clockwise direction so that it will be positive and the distance is 3, so 3 HA. This 40 is acting in the clockwise direction so it is also positive and the distance is 3. For HA we will get a negative value, that means the assumed direction is incorrect. HA is actually acting towards the left side, so we have to change the direction. Here I have changed the direction. Then by applying this rule, we can find Hg. For Hg, we will get 20 kilonewton. By using the rule number 3, we can know that the member forces CD and AG are 0. We can remove both of them. Now using the rule number 1, we can know that the members CE and CB are zero force members. We can remove them. Now again using the rule number 3, we can know that the member force in AB is 0. We can remove it. We have removed all of the zero force members. Now let us take the joint D. Using the rule number 5, we can find FDE as 20 kilonewton and it is tensile. Now let us take the joint E. Using the rule number 4, we can find the member force FEF as 20 kilonewton and it is tensile. Now we can take the joint B and we can use the rule number 6 and we can find FBF as 40 kilonewton and it is compressive. Now we can take the joint G and again we can apply the rule number 6 and we can find FFG as 20 kilonewton and it is compressive. We have found all of the member forces except in AF. We can take the joint A and apply this rule and find FAF. 40 is acting upwards so that it will be positive. FAF is inclined. We have to make it vertical. To keep it vertical, we need 45 degree. FAF is acting downwards, so it will be negative, and we have to multiply with the cos 45. Finally, for FAF, we will get 56.57 kilonewton. Since we have got a positive value, it is tensile. Here I have tabulated all of the member forces. Now let us try with this example. This truss is symmetrical and loading is also symmetrical. In this case, we can easily find VA and VD. For that, we have to divide the load 20 by 2. In this way, for VA and VD, we will get 10 kilonewton. We know that the member forces in GB and CE are 0. We can remove both of them. Now the member forces in BF and CF are 0. We can remove both of them. We need to find this angle. Let us keep this angle as theta. We can use a tan formula. Let us take this triangle. In this triangle, opposite side is 3 and the adjacent side is 4 plus 2. So it will be 6. In this way, for theta, we will get 26.56. Since this truss is symmetrical, the member forces in AG and ED will be same. The member forces in GF and in FE will be same. And the member forces in AB and DC will be same. Only BC is coming alone. Let us take the joint A. In the joint A, first let us apply this rule. 10 is acting upwards so that it will be positive. FIG is inclined, we have to keep it vertical. To make it vertical, we need this angle. This angle is 90 minus 26.56, so it will be 63.44. FAG is acting upwards, so that it will be positive. For FAG, we will get a negative value, that means it is compressive. Now let us apply this rule. FAB is acting towards the right side, so that it will be positive. We have to resolve FAG in the horizontal direction. To keep it in the horizontal direction, we need 26.56 degree. Since FAG is acting towards the right side, it will be positive. We already know the value of FAG and it is compressive. Since it is compressive, we have to apply that as negative. For FAB, we will get a positive value, that means it is tensile. Now let us take the joint G. In the joint G, there are two collinear forces, FAG and FFG. Since both of them are acting in the opposite direction, both of them should be same. So for FFG, we just have to copy the value of FAG with the nature, which is compression. Now let us take the joint B. FAB is 20 and it is tensile. So FBC also should be 20 and should be tensile. Here I have tabulated all of the forces. Now let us see some more shortcuts. In this joint B, FAB will be equal to 20 kilonewton. It is tensile because FAB and 20 are acting in the opposite directions. The values of FBC and FBE will be same and in the same nature. Now FAB will be equal to 20 kilonewton and it should be compressive because both of these are acting in the same direction, and FBC will be equal to FBE. Here FAB should be equal to 20 kilonewton and it should be compressive. FBE and FBC should be same. Here FAB should be equal to 20 and it should be tensile. FBE and FBC should be same. Here FBE will be 0. FAB should be equal to 20 and it should be tensile. Here FAB should be equal to 20 and it should be compressive. FBC and FBE should be same. Now we are going to analyze this truss. In this truss, the member forces in PL and FH will be 0. Let us remove both of them. Now the member forces in PK and in IF will be 0. Let us remove both of them. We need to find this angle. Let us keep this angle as theta. Now we can use the tan formula. Let us take this triangle. In this triangle, opposite side is 6 and the adjacent side is 12. In this way, for theta, we will get 26.56. Since this truss and loading are symmetrical, the member forces on the left side and on the right side will be same. So we can find the member forces in any one of the sides. I am going to find them in the left side. Let us take the joint A. In the joint A, using this rule, we can find FAB. Then using this rule, we can find FAL. Now let us take the joint B. We know that the member forces in AB and BC will be same and they will be in the same nature. So for FBC, we can just copy the value of FAB with the nature. Now let us take the joint L. We know that the values of FKL and FAL should be same. So for FKL, we have to just apply the value of FAL. Now let us take the joint K. The values of FKL and FKJ should be same. For FKJ, we can just copy the value of FKL and FCK should be 20 and it is tensile. If this angle is 26.56, this angle and this angle should be 90 minus 26.56, so that we will get 63.44. We need to find this height. For the distance of 12 meter, the height is 6. So for 12 it is 6, but we need the height at the distance of 8. So we have to multiply with the 8. In this way we are getting this height as 4 meter. This height is 4 meter and this distance is 4 meter. So this angle should be 45 degree. Now let us take the joint C. By using this rule, we can make this equation. And using this rule, we can make this equation. Then we can solve both of them. Solving both of them, we will get FCD and FCJ. For both of them, we will get negative values. That means both of them are compressive. Now let us take the joint D. We know that the member forces in DC and DE should be same. In the joint D, we can use this rule and find FDJ. For FDJ, we will get a positive value. That means it is tensile. Here I have tabulated all of the forces. Now we are going to end this session. Thank you for watching this video.